Hello everyone, I am Punyakeerthi BL. Welcome to LangChain tutorial from Python to GenAI. In this series, we will learn how to move from Python fundamentals to building real-world generative AI applications using LangChain. We'll explore key concepts like agents, chains, memory, and model integration. Everything you need to start building intelligent AI systems step by step. So let's dive in and start today's session. Today's topic is text embeddings with OpenAI. We can transform text into powerful vector representations. Let's start with introduction. Our introduction is in our previous sessions on LangChain, we learned how to load data from various sources using document loaders and how to split large text into smaller chunks for processing. Now we move to third step, converting those text chunks into embeddings. We call it as vectors. This is one of the most important steps in building any retrieval augmented generation or chatbot system because it allows our model to understand the meaning of text in numerical form. In this lesson, we will learn what embeddings are and why they are needed, how to generate embeddings using OpenAI's API, how to securely use your API key and environment variables, how to store embeddings in vector database, for example, Chroma, and perform similarity search. Let's start with understanding what are text embeddings. When we work with natural language, machines cannot directly understand text. They need numbers. An embedding is simply a numerical representation of text. Each piece of text, word, sentence, or paragraphs is converted into a vector, a list of floating point numbers that capture semantic meaning. This means that similar text have vectors that are close together in multi-dimensional space. For example, AI is amazing and artificial intelligence is great have similar embeddings. I love pizza and the sun is bright have very different embeddings. So embeddings help our systems to measure how semantically similar two texts are, enabling powerful applications like search engines, chatbots, recommendation systems, question answering systems. So let's understand overview of techniques to create embeddings. There are many libraries that can generate embeddings. In this series, we will focus on three key techniques. OpenAI API, paid high quality embeddings, cloud based. Olama, it is an open source, local embeddings runs on your system. Hugging Face Transformers, open source embeddings using pre-trained models. These three methods are more than enough to cover most real-world use cases. In this video, we will focus entirely on OpenAI embeddings. So let's start with OpenAI. So step 1, we need to create an OpenAI account, and inside that you will need to add a small credit because OpenAI's API is paid. This small investment helps you to test their services, especially useful since the accuracy and performance of OpenAI embeddings are excellent. So step 2 is generate API key. Go to your dashboard, API key section, click create new key, secret key and copy it. Keys usually start with SK. Keep it confidential, never share it publicly. So these two steps we can do now. So I opened OpenAI platform, already have paid $5 and I have everything. So now I go to API keys section. Here I will create a new key. So it will ask the name. I will add as a test demo as name, and I will create a secret key. Once it is created, I am copying that one. You need to copy, otherwise it will not able to. You need to revoke and again you have to do. So next step is using environment variables to store the API key. We never store API keys directly in our code. Instead, we use an environment variable file. So dot environment file we can keep like this. Okay, let's see in my project I have dot environment file. Here OpenAI API key is there. What I will do, I will copy this one and paste it. Done, right? Now I said load it in Python. Python we can load like this from dot environment import like this, and when we have this function load dot environment, automatically it will load into our Python code and we can access it like this. Before going to that one, we need to install two important libraries. One is python.environment and LangChain OpenAI. So what I will do, I will take these two and I will go here. In our project, I have a requirements.text. Okay, so I will go to here. So I will check. I don't have any other python.environment already. It is there. So I will not install. Then I will open LangChain OpenAI. I will take this. I'll copy. Then what I will do, I will source virtual environment bin activate done. Then pip install -r requirements.txt. See, all requirements are installed properly. Now we are good. So next what we need to do, we need to load this. For that we need a code, new file, python file. So what I will do, I will save it as text embeddings. Okay, but before that I will add like open AI text embeddings, save. Now what I will do, I will load like this from dot environment. You can load the API keys will be loaded. So let's try to run. So if we don't have any error, then we can move. OpenAI text embeddings, right? It's no error. It is running finally. We installed the required library and loaded the API key. Let's create embeddings with OpenAI. Let's write simple code to create embeddings. First one is from LangChain OpenAI import OpenAI embeddings. Okay, from LangChain OpenAI library, I'm opening or importing OpenAI embeddings. Okay, that is done. Once it is done, we need to call embeddings, OpenAI embeddings. We have to call model, this model. So what is this model? Let's understand that. First we loaded API key, then we have this model is equal to text embedding 3 large. What is this? Let's have open embedding models. So we have documents for that. So what are embeddings and all documentation is there, whichever models are there. So these are the embedding models we have in OpenAI. Usage is priced per input token. Below is an example of pricing pages. So for each page, how much price it will charge and performance how it is there, max input what is there we will get, and use cases are there. Here you have text embedding 3 small, large and ADA 002. Okay, but in our case I am using text embedding 3 large. It is available in the documents. Please practice to read documentation to make you people to understand what models we are using. So I loaded the model, then we need to create an embeddings. So what we can do, I will take text vector embeddings embed query. So what we are doing, embeddings we loaded. So using that embeddings, we are creating embed query for this text. This is our text, small text. This is a tutorial on OpenAI embeddings. This is my text. Then what I will do, I will print vector. Okay. Also print length of vector, length of the embedding vector, because we need to know dimensions. So for that purpose I am running now. What it will do, it will load the text and create an embeddings. You are able to see vectors are numerical representations. See, we are able to see all the vectors we created here. Okay, these are the vectors. Here you are able to see 3072. 3072 is an dimension. What is that? Let's understand. So when executed, vector will contain list of 3072 numeric values. This is embedding representation of your text. Understanding the model. OpenAI provides several embedding models. So text embedding 3 large, most capable of 3072 dimensions. If I use small one, lightweight, and it has 1536 dimensions. If needed, you manually set dimensions like 1024 to reduce the size. What we can do, we can have same query with different query with 1024 embeddings. What I will do, you come to know, I will comment this because it charges for each and every run when we are doing. That's why I am creating embeddings is equal to 1024 OpenAI embeddings. We are using the large one only, but we manually changing it. Default, if it, here we didn't change anything, manually we are changing it to 1024 because its default value is 3072. Now we are changing that to 1024. Text is equal to OpenAI embedding example, then vector 1024. So embedding 1024, creating the text, and length of the vector. I'm not going to print the vectors which we have, but we can see the length of the vectors created. So I will say once again code and let's run. So it is creating embeddings. Length okay, we we uh, didn't print the length of this one, that's why we are not getting. Again I'm trying to run. So it is running now 1024. So the embeddings are created with 1024 dimensions. This is how we can manually change the dimensions for the embeddings. This shows how the same text can be represented in different vector dimensions depending on your needs. Let's learn converting documents into vectors. Imagine you have a long document or a text file. You can split into smaller chunks using a recursive character text splitter, which we learned in previous videos. Convert each chunk into an embedding vector. That is what our concept. So first what we will do, we will load these two things. One is for recursive text. So I will comment this. Now what we are going to do, I will load this. These are the importance. First one is for the text splitter. We need to split the text into recursive character text splitter using this one. Then what we need to do, we need to load the file and we can see which file we are going to load. Here we can see text data demo, which contains, this is the data we have. LangChain is a powerful all data we have. Okay, this data we need to convert right into embeddings. So we need to load that one. How to load? Next step is loader is equal to text loader. We have to load this file. Then we need to convert into documents. This is the step. In this step, what we are doing, we are loading the text data demo into loader and converting it into documents. It is successfully loaded. Suppose remove this. Done, right? Now I need to split. Then we need to create a chunks. So what I will do, splitter is equal to recursive character splitter. Chunk size is 500. We learned this in last. So chunk size, what it will be, overlap, everything we learned. Now chunks will be split into documents and we will have this data. Okay. Once data is loaded, number of chunks we can see how many chunks it is created. Then what we will do, storing embeddings in vector database. So we are not done. You can see length of see 3 document chunks are created. Now what we will do, we need to store. So storing embeddings in vector database. Creating embeddings is only half the story. We also need to store and search through them efficiently. This is where vector database come in. We will use ChromaDB, an open source vector store that integrates easily with LangChain. So pip install ChromaDB. So we need to install the ChromaDB. That's why I will go to my code base. I will go to requirements.txt. I will add here. So we need to install the ChromaDB. So what I will do, pip install. So we need to type install -r requirement text. So it is installed successfully. Now what we need to do, we need to write a code. So now we need to, from LangChain vector stores import chroma, but this is wrong. What we need to do, we need to import. Okay, we need to import, right? We need to import like this from LangChain community dot vector stores import chroma. Okay, we did that. So chroma is imported. Now what we need to do, db is equal to from documents, chunks and embeddings we are passing. See, db is equal to chroma from documents, chunks, embeddings. Okay, we are passing that one. From documents we are storing. Perform a similarity search using our query. Next topic is what we are doing. We are querying what are OpenAI embeddings, right? This is the query, but similarly we have to find, right, what is the data we have. So we can take, for example, I will search, we have a collection. This is my text. So what I will do, I will add this. For example, suppose you have a collection is my question. I need to search this similarity search and we need to print the page content. What it will print, we can see. We are running, chunks are created and it is searching in the DB. You are able to see For example, all the data it is loaded related to, see how, this is how the similarity search or semantic similarity, we will retrieve the most relevant text chunks from your database based on semantic similarity, putting it all together. Here is the complete flow. We data ingestion, we loaded our text or document. Then text splitting, break large text into smaller chunks. Then vectorization, convert each chunk into embeddings using OpenAI. We storage, save embeddings in vector database like Chroma. Retrieval, query the database using similarity search. Each step builds the foundation for advanced RAG applications like chatbots that recall document knowledge, context-aware question and answer system, search systems powered by semantic understanding. Let's wrap up. In this session, we learned how to understand what embeddings are and how they matter. Use OpenAI's API to generate high-quality embeddings. Securely handled API keys using environment variables. Store and retrieve embeddings using ChromaDB with similarity search. In the next lesson, we will explore open source alternatives for embeddings using Olama and Hugging Face, so you can run them locally without relying on paid APIs. Let's quick recap that same thing: load data using document loaders, split data into text chunks, convert text into vectors, we call it as embeddings, store vectors in database, Chroma, perform similarity search on queries. Coming up next, generating embeddings locally using Olama, using Hugging Face for open source embeddings models, combining embeddings plus vector stores into LangChain pipeline. So thanks for watching today's session. This was part of LangChain tutorial from Python to GenAI. If you found it helpful, please subscribe to my channel for more lessons on building with LangChain and generative AI. Also feel free to connect with me on LinkedIn. You will find the link in the description. See you in the next session. Thank you very much.